Analyzing urine samples. The chemical and physical composition of urine can vary dramatically with diet and metabolism. However, the analysis of urine is still useful to diagnose disease because urine composition mirrors blood composition. This video will briefly describe urine formation, connect the processes of urine formation to abnormal constituents in the urine, demonstrate how to use a urinometer, and demonstrate how to use a combination dipstick. Urine is the end product of three key processes: glomerular filtration, which passively moves small substances from the blood to the filtrate; tubular reabsorption, which reclaims solutes that need to return to the blood; and tubular secretion, which selectively moves substances from the blood into the filtrate. The filtration membrane for glomerular filtration is porous and doesn't usually allow molecules larger than 5 nanometers to pass through. Therefore, the presence of molecules larger than 5 nanometers, such as proteins and blood cells in the urine, often indicates a problem with the filtration membrane. Glucose easily passes during filtration and must be reabsorbed. These mechanisms can become overwhelmed if blood sugar levels are too high. Glycosuria is the presence of glucose in the urine. Which of the following would be associated with glycosuria? High blood pressure, low blood pressure, uncontrolled diabetes mellitus, dehydration. Whenever there is excess glucose in the filtrate, there is a possibility that some of this glucose may spill into the urine. This is most often due to uncontrolled diabetes. Specific gravity is the relative weight of a solution when compared to the same volume of distilled water. The specific gravity of normal urine should be between 1.001 and 1.030. Drinking a lot of liquids could result in dilute urine and therefore a low specific gravity reading. A urinometer is a hydrometer that measures the specific gravity of urine. When using a urinometer, gently place the meter with the weight into a cylinder that is about 2/3 filled with urine. The meter should float freely. The top of the meter reads as 1, with 3 zeros to the right of the decimal. The values to the right of the decimal point are read by drawing a line beneath the meniscus of the fluid and reading the meter like a ruler. For example, the specific gravity measured here is 1.013. Dehydration can result in concentrated urine. Would dehydration lead to a high or low specific gravity reading? The more concentrated urine would have more solutes per volume and would result in a high specific gravity. Combination dipsticks provide a quick and convenient way to measure multiple urine constituents at the same time. With gloved hands, dip the strip into urine, blot the strip on a paper towel, and set a timer for 2 minutes. After 30 seconds, begin reading the colored pads on the strip. The first test read is glucose, which is the colored pad that is closest to the handle end of the dipstick. For each colored pad, use the key on the container to approximate the value for each constituent listed. Continue reading from the bottom up, matching each colored pad with the key and reading at the time indicated. Record your results. Note that you may use real or artificial urine in the lab. In either case, remember to wear gloves and dispose of used materials in the biohazardous waste container.